Started the inverse of cubic functions, no restrictions, make them simpler. So you can just dive right into the process, changing your function to a y, switching variables, solving for the y, and writing it into inverse notation. Whoa. Looked at that. My cursor, I'm sure. Then the graph then follows. You can see an original downward moving cubic function would be symmetrical across the x equals y. Or the graph. Simple as that. Okay, number 9, I don't think has a graph. No. Yep. Number 9 is just doing the math. Just the neat thing about cubic functions is that there's no restrictions. So I can take the cube root of a negative number. You can verify that on your calculator. You know, just throwing in any negatives into a cube root function, you've got it. So switch to a y. Switch variables. And then solve for y. So I have to add 3/4 to both sides. And the hardest part for number 9 is typing it in. So you have to make it a cube root. You have to pick the tool that has the box up in the radical. Don't put it next to it. It's got to be up here. You don't make it superscript. It's got to be this particular software tool. And then we have the x plus 3/4. So that is our inverse. And they remind you, if I took my function and put it inside my inverse, I'm going to get x out. So you have to type this in a couple of places for the inverse function and then finish the sentence that this is called a composition. If I put the two functions, one inside the other, either way, you're going to get an x out. So if I put this cube root up in here, cube root cubed goes away. So what's left is x plus 3/4 minus 3/4, and that's x in the end. I put this little story in here. I've got x cubed minus 3/4 plus 3/4. That makes the 3/4 go away, and then the cube root of x cubed is x. So for number 9, they'll ask you to put in that value. They'll have the inverse, put the value in, and finish the story with the inverse. So if I give you a cubic function, you should be able to tell me the inverse. That's what the assessment's going to be like. Okay? I think, I'm looking at my number 8, I think I have my symmetry wrong. That's okay, leave it there. Okay, number 9. Number 10, there we go. Okay, the original function is a cubic function, so there's no restrictions. Odd, you can't see. And you should be able to write the inverse. If you know the inverse of add, subtract, the inverse of cube is cube root. Your inverse, you can write all the steps, do all the heavy lifting, but it ends up being the cube root of x minus 9. So I can, because what we've done, the hard work, we know it's going to be the inverse operations of what you see in the original function. going to have you say again, if I put this inverse, the original inside the inverse, I'm going to get x out. So you're going to end up typing that twice, and that's once. There's a couple of context problems where you see the inverse functions in action. If I have a formula given the radius of a metal ball, and depending on the metal will be the multiplier here. It didn't say the metal in our question for number 11, but this is the formula for a metal ball. If I'm given the radius, I can find the mass. They want you to rearrange this formula so if I give you the mass, you can find the radius. So that's kind of an inverse function. So I'm going to change the function notation, quote unquote, to just variables. M equals 19r cubed. And we're not switching variables, we're just solving for the r. This is what you do in your science class all the time. They give you a formula and you need to recreate it so that it's useful to you. So I have m over 19 is r cubed. And I take the cube root of both sides. And now I have my inverse function. It's the cube root of m over 19 is the function where you're given the mass. Then you find the radius. Oh, I only wrote a 9, sorry, 19. There we go. So that was an easy context. Hopefully you remember doing that kind of stuff in science. You're given, they're called literal equations, and then you solve one for a different variable. So that's where the rubber meets the road. Algebra is only as useful as you need it in solving problems. Now it does help that you have the mind of a problem solver. That starts with reading the story and then deciding what you need to do to find the solution. 12 says the function x squared must have its domain restricted to have its inverse be a function. The function x cubed it does not have to have. So f of x equals x squared needs restriction. If you remember from the first ones we did, so its inverse is a function. F of x equals x cubed doesn't. Am I still on the screen? Yep. Need restriction. There we go. So it wants you to take this beyond just squared and cubed to other power functions. So it says drag and drop the words into the boxes to make a conjecture about which power functions need to have their domains restriction and which ones do not. So if 2 is your power, 4, 6, 8, 10, 12, they would all need restrictions. So your even functions need restrictions. Because if you took the fourth root of a negative number, it wouldn't be a real number. Take the eighth root of a negative number, it wouldn't be the real number. But if you take an odd root, any odd function doesn't. And you can test it out. Okay, if I try to take the 6th root of -3, it says domain error. But if I take, let me see, I'm going to clear that. Remember how to do the 7th root? You put in your root, and then you hit your 2nd, and then you put in your function above the caret. Your 7th root has to be, you put in your what root you're taking, and then you hit your 2nd, and then this caret button here. That'll give you something beyond the square root there. And then if I put a negative number in, like -3, see, it's an answer. It's not rational, it's irrational, but it's still an answer. It didn't say domain error. So that's just one little dip in the ocean of the universe where we can observe that even functions do need restriction, and odd functions don't. And that's your assignment. Now I'm going to go back to number 8. I messed up on this picture, I see, after I step back and look at it. Okay, this little twirly bird, I translated it, but I didn't reflect it. So, and I don't know if you want to mess with changing it or not. I'm sure you found the right one. I should have had it above going below. There we go. So these two would be the reflection. So I apologize for that for number 8. If that confused you on the graph. On the homework, it was pretty obvious which ones were symmetrical. Hopefully you didn't have any problem finding the right. There we go. The right see, those aren't symmetrical because whatever's on one side has to be on this other side. So that was missing. This one doesn't even have a second graph. This one's not symmetrical because what's on one side, it's got to be on the other side of this. So D is tricky, but yeah, that doesn't, if you put this in the decimals, that wouldn't give you what you need. So that's what number 8's graph should look like. So the rest time is yours for Algebra 2. If you have missing work in Algebra 2, that's what you should be on till 12:40. If you're not missing work in Algebra 2, celebrate and you'll have another subject to study. But I'm thinking most of us need at least to finish 10.1. That's what I want for you. You don't want the assessment to show up and you're not done with the homework. So thank you.